Hi there, and welcome to our first lesson in the solutions unit that we are going to be doing during our remote learning. And just so you know, today I'm going to review a couple of the terms that you need to know when we discuss solutions, and then we're going to start talking about how we describe solutions. In particular, we're going to talk about molarity as a way to describe solutions. And luckily, you guys are already familiar with molarity because we discussed that back in first semester when we learned about molarity and doing stoichiometry problems and calculating moles. Okay, so let me start. I'm going to present this screen. We'll see how this works. And first of all, I just want to make sure that you understand why we are studying solutions in the first place. And as you have probably noticed throughout the semester, many times when we do chemical reactions, the molecules that we're looking at or that we're working with are in solution. So solutions are a really important part of chemistry. So the next couple of slides are really a review of stuff that you probably learned in middle school, maybe even late elementary school, physical science. When you take two things and you mix them together, what you get is a mixture, right? What is important to note about a mixture is that there's not a chemical reaction when you mix those two things together. In other words, you could separate the substances back apart. We'll talk more about that in a second. And so I have some examples here on the slide. What we are mostly concerned about is when you have a solution, and the difference between these three things, suspension, colloid, and solution, really has to do with the size of the particles. So obviously sand is way bigger than salt molecules, and that's why sand filters down to the bottom, which is what makes it a suspension. Protein and fat that are mixed into water are larger, but can still dissolve into and be spread apart and stay mixed in the water. And then you have our solution. And we're only going to focus on solutions. We're not worried about the other two terms. Okay, so I just have a couple of pictures here for you of these different things. Okay, and then, like I said, what we really want to focus on is this term solution. And you very much need to know that a solution is made up of two parts. A solution has the solvent, which is the substance that does the dissolving. And then you have the solute, which is what is dissolved into the solution. Most of the time, the solvent is going to be the water. Or is going to be water. In fact, water is known as a universal solvent because it can dissolve so many things. Probably with the remote learning and stuff, we won't do any tricky problems involving something besides water that is a solvent, but it's 100% possible for it to be other things. Now, here's one more important thing that I really want to make sure that we understand about making a solution, and that is that it's not a chemical reaction. So when you take salt and you dump it into water, it just dissolves. In other words, it spreads out. And so the salt is still salt, right? I could boil all the water off and be left with salt. It might be in a little bit of a different form, but it is still salt. Okay, huge thing for you to understand. And then, like I was mentioning before, you can have solutions besides or made of things besides just water and solids, right? Like you can have alcohol and water mixed together, or the carbon dioxide dissolved into your water is a solution. You can have air is a solution. Technically, the air that we breathe is a solution of all kinds of different gases. Okay, none of this stuff you need to write down. We're just getting some introductory material down about solutions. Okay. One other important thing that I want you to know about solutions, what sets them apart from other substances, is that they cannot be filtered. So that's how small the particles are once they get dissolved. So like I can't take salt water and run it through a filter paper and pull out the salt ions. I'd have to do something else, as I mentioned, evaporate or boil off the water, and then I could get my original substance back. Okay. One other term you guys need to be familiar with is that term dissolving, which I've already used a couple of times. What that's referring to is how a solution forms. And so water, for example, with that polar shape that it has, is able to pull apart many, many, many different molecules. So when something dissolves in water, the water is literally pulling the molecules apart from the original big chunk until all of the molecules are completely separated. And if you remember, we talked just a tiny bit in first semester when we were talking about bonding that molecules have different shapes. And when they have similar shapes, they're better at dissolving things. And also from the video that you guys watched about the coronavirus and soap works so well at killing the coronavirus because soap and the coronavirus have a similar shapes or similar molecules that make it up, and the soap is able to dissolve the fatty lipid layer that makes up the outside of the virus. Okay. So next thing we're going to talk about is, like I mentioned, how you describe solutions. We can do that qualitatively or we can do that quantitatively. Remember that qualitatively means words. So we describe things with words, and quantitatively means numbers. So we're going to actually have values. So we aren't going to get too much into this at the end of this semester, but there are 3 terms that we use to describe solutions that you've probably heard of in other instances. So, for example, we have saturated and unsaturated. You probably heard those terms in biology when you learned about saturated and unsaturated fats. What it's referring to is how much solute is dissolved in a solution. So in an unsaturated solution, there is less solute than you could technically fit into that solution at a given temperature. Keep in mind that when you warm up a solution, you can dissolve more solute into it, right? You guys all know that because if you've ever tried to dissolve sugar into tea, it's much easier to dissolve a lot of sugar into hot tea versus cold iced tea. So unsaturated has less, saturated has just the perfect amount that can fit in there, and then supersaturated is a solution where you actually dissolve more solute than is technically possible. And the way that happens is you start by taking a solution and making it really, really hot, dissolving a lot of stuff into it, and then cooling it off. In fact, that's how a lot of candy and stuff like that is made, is they get a whole bunch of solution dissolved and then cool it off, and then you're left with this super saturated solution. Okay, but those terms don't help us much when we need to actually do chemistry because they don't give us any numbers. We can't do any calculations. So that brings us to describing solutions quantitatively. Okay, and like I said, it's much more beneficial to describe them quantitatively because we get real numbers. There are 3 ways that we're going to learn how to describe solutions. The first one is what we're going to talk about today, which is molarity. And again, you guys are already familiar with this idea, which is moles of solute divided by liters of solution. The other 2 are new, and we'll talk more about those next class. We have molality, right? Sounds a lot like molarity, so we know moles is involved. Molality is the moles of solute divided by the kilograms of solvent. And then you also have mass percent. So mass percent is just giving you the mass of the solute in comparison to the mass of the solution. It's a lot more familiar in everyday instances. For example, if you were to go look at a bottle of vinegar, it talks about how vinegar is 5% acetic acid in the solution. But again, these 3 ways to describe solution are much more beneficial to us in the lab because they can actually tell us a number of molecules or atoms that are involved. And remember, that's very important to us when we do calculations. Okay. So what we're going to do right now is spend a little bit more time talking about molarity. Okay. This is where you might want to get out some notes because we're going to write down some information. Okay. So I'm going to switch over to my document camera now, and we're going to put down some information about molarity. If I can get this thing to work. I think I can. Let me grab a couple of pages here. Okay, so as we have mentioned, molarity is equal to the moles of solute per liters or per liter of solution. Okay, so I'm just going to write up here at the top of this paper, molarity. Anybody remember what we represent molarity with? It's a capital M. Okay, and so molarity is equal to the moles of the solute divided by the liters of solution. And again, with vocab terms, that solute is what's being dissolved. And then the solution, remember, is made up of the solute and the solvent, which is usually H2O. Okay, so that's our equation for molarity. So this idea right here is really important. You need to make sure that you know this equation, or at least keep it stored someplace that you can quickly reference it when we are doing this unit. So for example, if I said that I had a 2 molar solution, what that means is that there are 2 moles of solute for every liter, so for every 1 liter of solution. Okay, so that's what molarity tells us, is how many moles there are in a liter of a solution. And again, remember that the mole tells us the number of molecules. So molarity is ultimately telling us exactly how many molecules there are in a liter of solution. Okay, so that's our equation. So what I want to do right now is look at some example problems. You're going to go through and practice calculating molarity. Again, this should be very familiar to you because we did it in first semester. You have done molarity calculations when you are doing stoichiometry. But as you know, I posted a worksheet that has 4 example problems. And then it's got 6 more practice problems. That's going to be your assignment for today. So if you want, you can get yourself a copy of this, or you can just write out the questions on your own piece of paper, or you don't have to write out the questions. I don't care. That's really your note section. But we're going to go through those examples right now. So how did I already lose another paper? Let's see here. I'm going to check out example number 1. Okay. So example number 1 says, what is the molarity of a solution? Okay. So I'm just going to rewrite the equation here. Molarity is equal to moles over liters, right? What is the molarity of a solution that contains 0.75 moles of sodium chloride in 1.25 liters of solution? So this is pretty easy. I need to know moles and I need to know liters. So 0.75 moles, there's my moles, and 1.25 liters of solution. So all I simply do is plug those numbers in. So 0.75 moles divided by 1.25 liters. Okay. In terms of what you have to show on your paper for credit, I need to see you plugging the numbers into the appropriate spot in the equation. So you would need to have at least this on your paper plus your answer. So 0.75 divided by 1.25 equals 0.6. And again, we just calculated the molarity. So the unit for molarity is a capital M. Okay. So capital M is what we will use to represent molarity. Okay, pretty straightforward. All right, let's look at the next question. It says that there's 160 grams of sugar and enough water that is mixed together in a 200 milliliter solution. So what is the molarity of the solution? So again, molarity is equal to moles over liters. And notice that I don't have moles or liters in this problem at all, right? So that means I'm going to have to do some initial calculating. So I have 160 grams of sugar, right? Which is my solute. Can I convert that to moles? Sure, I can. Pretty easily, actually, as long as you know the molar mass of sugar. So you can look that up, right? C12H22O11. 1 mole of sugar has a molar mass of 342.3 grams. So the number of moles of sugar that we're dealing with is basically 0.47. And remember, we're going to just round to 2 decimals to make our lives a little bit easier. Okay. So now I know my moles. Next thing I need to know is my liters. Well, again, it doesn't explicitly tell me liters. It gives me milliliters. Okay, so do you remember, how do you convert from liters to milliliters? Or I'm sorry, milliliters to liters, I should say. You're going to divide by 1,000. Okay, so this fact, if you don't remember that, is something you need to write down or keep somewhere, probably in the same place that you're keeping this equation written out, so that you can easily remember how to do that. So 200 divided by 1,000 would give us 0.2 liters. So now I know my moles and I know my liters. I just have to plug it into my equation here. So 0.47 moles divided by 0.2 liters. So just plug that into my equation real quick. And I get 2.35. And again, we just calculated the molarity. So the unit for molarity is a capital M. Okay? Again, should feel very familiar. We have worked on this stuff before. Okay, let's check out example number 3. Okay, so example number 3 says, how many moles of sodium carbonate are there in 10 liters of a 2 molar solution? So anytime you see this capital M, the word you use for that is molar. Okay, and of course we know that molarity is equal to moles over liters. And look what we have. We have the liters, right? And we have the molarity. So we can plug those two values in and solve for moles. We're looking for moles. Okay, so we just get to do a little bit of a different form of algebra. So it's 2 molar is equal to some number of moles over 10 liters. Again, for work purposes, this is what you need to put on your paper, like as a minimum. You need to show me that you know where the numbers go in the equation. You don't have to show me much more than that, besides the answer. Okay, so how do we solve for the number of moles? How do we get X all by itself? Well, if we are dividing by 10 and we want to get rid of it, we just do the opposite, right? So if we want to get rid of the 10, then what do we need to do with it on the other side? Multiply by it. Very good. So I'm going to swing that up there. So I would have 10 liters times 2 molar is going to give me my number of moles. Okay. So 10 times 2 is equal to 20. And again, the unit here is moles. Okay. The other way you could remember this, we know this from our stoichiometry, is that for a solution, moles is equal to the molarity times the volume. See, isn't that what we did here? Molarity times our volume. Okay, so you can do whatever works for you. All right, last question, and I like this question a lot because this is a realistic question for a lab. If we had had normal school, we would do a lab or an activity where you would have to figure out how to make a solution, and I would actually have you guys make solutions. So it's very common. I do it constantly preparing for you guys in class. Is I know a molarity of a solution that I need for a lab, and I know the volume of a solution that I need, and so I have to sit down and do the math to figure out how much of this solute do I need in order to make my solution. And that's exactly what this question is asking. It says, how many grams of calcium hydroxide are needed to make 100 milliliters of a 0.25 molar solution? So first thing I'm going to do is convert that 100 milliliters to liters by dividing by 1,000, because I don't ever really deal with milliliters, and that is equal to 0.1 liters. And notice that I also have the molarity. So we're going to be using our molarity question. So molarity is equal to moles over liters. So if I go and plug my numbers in, I notice that number 1, I don't have moles, and number 2, there is nowhere that grams is mentioned in the question. So what do? Well, hopefully you're sitting there thinking, oh, well, I know how to convert moles to grams, right? And that's exactly what will happen in this problem. First, we'll figure out how many moles you would have if you had 0.1 liters of the solution and it was 0.25 molar. And then once you know your moles, you can convert that out to grams. Okay, so let's plug in our values. So we get 0.1, oh, whoops, I wrote that a little bit, not how I wanted. So it's 0.25 molar solution is equal to some number, I'm going to use X, number of moles over 0.1 liters. Okay, and so I'm just going to do some cross multiplying here. And I'm going to get, so I'm going to literally multiply 0.25. Maybe if I can turn this on. So 0.25 times 0.1. And I get 0.025 moles. Now again, the question asked for grams. So I have one more thing I need to do. I need to convert this number of grams out to moles. Well, what do I have to know about calcium hydroxide to convert from moles to grams? That's correct, the molar mass. And I, before the video, figured that out. 1 mole of calcium hydroxide is equal to 74.09 grams. So I can write that into my equation here. I put 1 mole on the bottom so the words cancel, and then the 74.09 grams on the top. Okay, and then I just have to take 0.025 times 74.09, and I get 1.85 grams. So if I wanted to go and make the solution in the lab, I would get myself a container and I would measure in 1.85 grams of the solute, in this case calcium hydroxide, and then I would add water until I had exactly 0.1 liter, until I had exactly 100 milliliters. And then I'd give it a good shake and I would have my solution. Okay, so those are the 4 types of problems that you are going to have to do in this practice. That's it. All I'm going to have you do today is molarity. You've got 6 more problems to work on. So again, if you go back and look at this page, these are the 4 example problems that we just worked through. And then you guys on your own are going to do problems 5 through 10. Okay, I am posting the answers. They're already posted on Google Classroom, so you can do your work and check your answer. And then when you're done with this assignment, you will take a picture and submit it up onto Google Classroom. Please note that I'm not going to give you any credit if you just had the answers, because we all know that you just copied them down, right? So make sure that you show me at least the number set up in the equation. You don't have to show me like the math necessarily, but the numbers put in the correct spot into the equation. Okay, so if you have any questions or concerns while working on that, please reach out to me. Don't do the assignment and don't understand it and then submit it and then tell me later you didn't know what's going on, right? Ask right away. I'm just sitting around waiting for your questions, okay? And then next class, we'll talk about molality and mass percent. All right. Have a fantastic day.